This is a hands-on workshop, which means you need a computer, you need to be able to sit and work. So if you want to stay, if there's no place for you to sit, if you want to stay, it's fine. We don't mind at all. You can take the workbook and maybe try it by yourselves at some point, but it'll be very difficult to do most of the work here if you're standing. You probably won't be able to do it because you will need a laptop.
I have an idea. You have added another URL here. Maybe you can create an online Google Doc document and share it. And if you add some stuff, some links, so we can just access it right from our website.
Sorry?
You could create an online, this page online and Google Docs or something and share it. And we can click links, not just type them.
That's what we did. That's the second.
So the second link, the bit.ly link, is a Google Doc. Yeah. So right. So just to clarify, we normally have handouts of the PDF. We're from Canada, and it's very difficult to get here. It's like our flights were very long, so we didn't have time to print everything. So that's why this is kind of half-assed. So we're sorry about that. Normally we pre-printed, but yeah. Yeah, so if you guys go to the bit.ly link, the one that says workshop, warning, don't click yet, go ahead and click it. Oh my God. Yeah. Oh, okay, so I've said, sorry for everyone who's heard me say this a million times. So for everybody who's standing, I just want to let you guys know, everybody's coming in late. I just want to let you know that this is a hands-on workshop, which means that you'll probably need a laptop in front of you and a place to sit in order to complete most of it. So if you want to stay, I mean, there's not enough room. If you want to stay, you can maybe take notes, maybe try to do the workshop offline, but the majority of what we do here today, you won't be able to do it standing up. You'll just be sitting there. So I just want to let you guys know in advance if you want to check out something else. If you want to stay, it's not a problem. Just it might be frustrating because a lot of this is hands-on, and you won't be able to do it. For everybody who does have a seat, make sure you go to that bit.ly link where it says workshop, click me. There's a Google Doc there. In the Google Doc, there's a link to the PDF. There's also a link up here if you guys want to type it out. And you can download the PDF. The PDF is a workbook, which we'll be working off of today. It has all the information in it about the different workshop stages that we're going to be doing, as well as some extra stuff that might help, some references and some extra notes that aren't in the slides. So if you want to download it, it's probably a good resource. Also, there are more people coming in. I'm not sure why.
Just relax and start the workshop.
Yeah, I think we'll... All right. All right, so from the crowd, they want us to start, so we're going to start. Okay, so we're starting. So crowdsourced malware triage, that's what you guys are all... I have to hold this up to my mouth. That's what you guys are all here for. My name is Sergey Frankov.
I'm Sean Wilson. Sean Wilson.
There we go. Sergey, Sean. So we put our emails up here. If you have any questions after the workshop, because I'm not sure we're going to be able to get through everything today, just judging by how many people are here and whatnot, shoot us an email afterwards. We'll answer it. It's not a problem. We're just here to do this for you. We're not paid. This is just something free that we do, to help other people who are like in our position a couple of years ago when there was no training like this. So that's why we're doing it. We're always happy to respond to your email. If you have any questions, comments about what we're doing, send us an email and we'll respond to you. So now, we put this slide in. It's not to frighten you or anything, but it's important to note that we're using real malware. We've developed the malware. We're also using real exploits, which we have developed. we developed them in such a way that they won't actually harm your computer. If something gets away from you, you accidentally run them on your computer, it won't cause you any harm. We've been specifically chosen exploits that are not going to trash your computer. We specifically wrote malware that's not going to infringe on your privacy or anything like that. However, if you do have a company laptop, you have AV on it, maybe you have like some agents, they're going to go nuts. So if it's your own personal laptop, we suggest that you disable AV for right now, just for the workshop. If it's a corporate laptop, then you really have to figure out what your policy is on running malware on your corporate laptop. If you can't do it, if you don't think that it's legitimate, if you can't check maybe with your boss before you came here or something like that, we recommend you don't do it, because this will flag, this will pop alerts, and if you have like a SOC or somebody monitoring what's going on, they're going to freak out. They're going to think that you're popped. So just fair warning for everybody in here who's going to do the workshops, just be aware of this. So, what is malware? Well, it's just code, right? It's just software that's developed. So our philosophy here is that we don't have to go into the specifics of, what is this malware, what is that malware. We think that if you understand software development, if you're a developer, if you have some background in web technologies, you can write some JavaScript, maybe you've written some C or some Java, you should have no trouble completing this workshop. It's not very advanced. We're not using debuggers. This is done in such a way that you can complete it even if you've never been exposed to malware before. However, the process that we're teaching you is a process that you guys can use once you come against something that is maybe more advanced. So we're going to teach you kind of a basic step-by-step process that you can use, and we're going to use very simple technology, very simple malware, but it's not to say that this process isn't going to be applicable if you come across stuff in your daily job that's going to be much more advanced. So this is kind of like our layout of what we're going to be teaching today. So we're going to talk about malware triage, and I'd like maybe just a raise of hands. Anyone in here who works in a SOC or incident response, can you raise your hand? I just want to see how many people we have here. And anybody who's working on the defense side, so not penetration testing, but security architecture, anything like that. Okay? And then how about pen testers, people who are working on the offense side? We have like one, okay, mostly defense, or shy people who don't want to put up their hands, that's okay. So if you work in a SOC, you're probably already familiar with malware triage. If you don't, I'm just going to explain really quickly. Triage is not analysis. So when you think about malware analysis, this is trying to figure out everything that you can do to understand what's happening with malware. This is not the same case with triage. With triage, what you want is you want to quickly come to a decision, do I need to do malware analysis? Or do I not care about this? Is this a false positive? Or is this exploiting some old exploit that I don't care about? So that's the process that we're going to teach today. It's geared towards having a very quick answer, do I need to look at this further? And in a corporate environment, this is really important if you're running a SOC or if you're running incident response, because you may have even big FIs, you may only have 4 or 5 incident responders who really know their stuff. These are high-paid guys, right? With triage, what you can do is you can have a bunch of junior people doing triage, much less expensive, and they're basically the gatekeepers to your incident response guys. So they're doing this process, they're not going in depth, and they're figuring out, do I need to pass this on, or is this something we don't care about? Is it a false positive? Is it something old that we've already covered off? This is the reason why we have the triage process. So it's basically in a corporate environment, this is like, is it malicious? Like, what am I looking at? Is this actually malicious, or is it a false positive? If it is malicious, what is it exploiting? Is there an exploit, or is it social engineering? And if there is an exploit, or if it is social engineering, do I have any exposure? Do I care about it, right? If my company is already like tooled up, we don't use Java and it's Java, well, we don't care. We don't have to go any further, right? We can stop the process. We don't engage our incident response team. We don't waste any money. So that's the whole point of malware triage. That's what we're teaching here today. It's not malware analysis. If you guys are already, like if there's other people in here who are like living in IDA every day, this is probably not for you. This is going to be very boring. If maybe you haven't done a lot of incident response, maybe you're junior, maybe you're SOC, maybe you're in security defense, but you're not actually doing incident response, this will probably be interesting, okay? So, talking about triage and where it fits in your organization, it's very important. As we teach this, we don't want you guys to go away and be like, oh, we're malware analysts, oh, we took a course. We want to be very clear about where malware triage works and where it doesn't work. So it's very effective if you catch something, an intrusion in an early stage. So right here we have the Lockheed kill chain, which probably everybody in incident response is familiar with. This is like the normal stages that happen during an intrusion. So malware triage is only effective if you catch an incident in its early stage, so in its delivery. If you catch the email that's coming in and you want to figure out what's going on, or you have an alert on a link, this is important to use triage in these scenarios. If, however, you catch an incident later on, so there's already an infection, maybe there's some beaconing out, maybe there's some connections out to a C2, triage is not effective. You want to get right into your incident response with your true analysts at that point. So your triage program is already done. The only area where it's effective is early in that kill chain process, where you don't really know what's going on yet. There's maybe not any infection. You've just been tipped off that there's a weird email that you need to look at. This is where triage is very effective, okay? So we've geared this workshop to be done only with online tools. So you don't need anything locally. You just need a browser and a notepad. But you do need a browser and a notepad. So some guys who had phones, it's probably not going to work for you guys. So, I mean, you could try it on the phone, but you probably need a laptop. For each section, we're going to sort of teach you the methodology, and then we're going to hand it off to you guys to actually go and work through a scenario. So for each section, there's going to be an accompanying hands-on scenario, which is why I keep on saying you need a laptop, you need to be able to sit down. For everybody who's standing, maybe you get the first half, but the hands-on stuff you won't be able to do. So with that being said, though, in your workbook, if you guys download the workbook, there's a lot of links to local tools, which you can use if you're going to be doing triage every day. So here we're teaching you how to do it if you literally have no tools at all. You just have a browser. And we've kind of geared the course, kind of like you'll see there's some tools that we're using, which you normally would just use the local equivalent. But we've structured it in such a way so that you guys don't have to worry about downloading stuff. That's why we've done it this way. However, if you're going to be doing triage after this course, if it's going to be part of your normal daily work, then you probably want to use the links in the workbook to actually download some local tools, because these probably aren't going to be the most effective tools. So the crowdsourced portion is basically just what I was talking about. These are all the online tools that we're going to be showing you guys today. What we've done is we've created a scenario, like I was saying, where you'll actually work through the scenario instead of just giving you a list of tools and being like, here they are, go for it. So we're not doing that. We're actually going to show you how each thing works, and we'll have you guys kind of work through it yourselves with the tools. Here's just a sample of some of the ones that we'll be using. So if you guys are going to bring this triage back into your organization and you're going to be doing triage at your work, we do want to give like the standard warning here that obviously these are online tools, and whatever you upload to them is going to be available to the people who run the tools, or in some cases to anybody who can see it. So like if you guys are familiar with VirusTotal, if you upload a sample to it, anybody can see that. So if you think you're working with some malware that maybe is targeted, maybe it's not generic, something smells wrong about it, just be aware that maybe you don't want to be using these tools. These tools are very effective with crimeware, generic phishing type stuff. It's very effective because you don't care if they know that that you're onto them. But if you're dealing more, like if you're working in defense or an FI or something, you have a lot of targeted stuff, maybe this isn't the best approach. So I just want to put that out there, as like a disclaimer, because I don't want any like crying emails later, you told us to upload these files and no, whatever. So just a standard disclaimer. Okay, so the scenario that we've concocted for you guys is like really standard for everyone who put up their hand, says that they've worked in a SOC. You've probably seen this like every day. So for our scenario, we have a suspicious email with a link in it. That's all we have. This is a really standard in an organization. This is where you would start your triage. This is the most effective scenario for triage. One of your employees says something's wrong about this. I don't know. I don't know this person. And you got to figure out, is it malicious? If it is, what is it exploiting? If it's exploiting something, do we have exposure to it? If we have exposure to it, what is the payload? What are they trying to do? How do we protect our organization? We're going to go through that whole process using this sort of starter email. Now, the way that this works is we have a fake scenario here. It's not the same scenario that you guys are going to be doing hands-on, but it's very similar. So you guys are going to have a link, we have a link. It's just we've done it that way so that you guys can't copy what we're doing exactly. You still have to do a little bit of work yourselves. So this is the triage workflow that we're going to do. It basically goes through the whole process. as if you are working through triage in a corporate environment, and this is your standard process. This process will obviously change depending on where you are, what your organization is like. We've just shown you every step that we think is needed. If you guys are doing this day to day in your organization, obviously you'll start dropping steps. You don't need to do them all. We're just showing them all to you so that you have them if you need them. The focus of this triage is going to be on an exploit kit. This is one of the most common intrusion things that we see. Next to phishing. Phishing is pretty far up there now, but this is more interesting. So we're going to do an exploit kit, which means that it's going to be mostly web-based stuff. We have another workshop we can talk about documents, but that's not today. Today it's all exploit kit-based stuff, online, HTML, JavaScript, all that sort of stuff. So for this, we have a couple steps. I'll just go through them really quickly, and then these are the sections that are going to make up the workshop. For each one of these, you're going to have a hands-on workshop that kind of goes along with it. So first, we have passive analysis. This is basically getting some recon on the target without actually interacting with it. So this would be if you have a link, maybe like looking up the domain where it's registered, that sort of stuff. No interaction. Initial interaction is exactly what you think it is. So it's the first time you hit it. So if it's a URL, whatever you download, if it's a document, the first time you open it. Web component analysis, again, is specific to this workshop because we're doing an exploit kit. So this is where you try to figure out what's actually going on. So if there's obfuscated JavaScript, you de-obfuscate it. If there's like some weird HTML stuff, you take a look at that. Then we move on to exploit analysis. So this is where, it's pretty much self-explanatory. It's where you identify what the exploits are. Then we go to payload extraction. So as everybody knows, there's a reason why people use exploits. It's to get some sort of code execution. So we want to figure out after they have code execution, what do they want to do? This is like the goal of the malware. So this is payload extraction, payload analysis. And then last, we probably won't have time for building IOCs, but we'll at least touch on it. So this is not a full, we have another workshop that it's full on, 3 hours on building IOCs. That's definitely not going to happen today. We're very limited on time, but we will at least touch on it. And there's a lot of stuff in the workbook. If you guys, if you feel like it's cut short, there's a lot of links. And again, you can always email us with any questions you have, and we'll answer. It doesn't matter if it's next week, next month, next year, we'll still answer your questions. No problem.
And passive analysis. Hey, guys. My brain still thinks it's 4 a.m., so excuse my stuttering. So as Sergey said, the first thing we want to do when we get something into our SOC or in the incident response process is get as much information as we can about it without actually sending anything out. So we want to do this because if it is targeted or if it does look weird, you probably want to kick off an incident response process that does not use any of these tools. So the first thing we can do is, everyone's probably aware of VirusTotal. VirusTotal also allows you to scan URLs, or in this case, the host. So we can enter it in and see if they have any matched results. So you can search by a host. And we can see that it has a few malicious hits. So we know it's probably not targeted because other people are uploading it. And we know that the user is probably right to send it to us because it's looking like it might be bad. One thing to be careful with this, though, is that if it looks good, like it's all green, it does not mean it's clean. It just means that they don't have a signature for it. So you can use it to prove bad. You can never use it to prove good. Another great site, there's a few of these. We use Bluecoat, but we can get the category for it. So does the proxy know about this host or this URL? In the case of the URL that they sent us, it is malicious. So we can see that we have 2 hits already. We haven't interacted with the site or the malware, but we know that it's probably malicious. The user is right. We hope they didn't click the link, but they probably clicked the link because they always click the link. So Passive Total, this is a great tool. Again, it's free. What it allows you to do is search kind of history of a domain or an IP. It also allows trusted people to add context into different artifacts. So in this case, we can see it's tagged with Sweet Orange. It also has a classification of crimeware. So we were right, it's not targeted, it's probably crimeware, and it's probably this thing called Sweet Orange. So we've not done anything, but we've still gotten a fair amount of information about, the link and the phishing email, and we've done nothing, right? Completely passive, we know, yeah, this is bad. Who else got it? Let's start pulling some indicators out of this. Something that people often overlook is also domain and whois info. So if you have someone, if everything's clean up to this point or looks clean, but you do a quick lookup on the domain and it was registered yesterday, there's probably something fishy going on, right? Like that usually doesn't happen. So we can see with here if there's a lot of IP changes. So if it's something using Flux, if it was registered yesterday or even today at times, it's again another kind of point to say, yeah, this is malicious. We're going to have to kick off triage. It's not targeted. It's probably crimeware. So we're good to go. So when we were doing this, we did have a workshop for passive analysis, but we decided against faking reputation because we'd probably make some people angry because we'd have to seed passive total, all the big IDS folks, and it just wouldn't go over too well. So we do have a workshop in here that you can use, and you can kind of go through the steps, but we didn't fake it. So, these are obviously really simple things to check, but it's just always do this first, right? Because this is your first decision point.
So I do want to add that if anybody wants to actually try these tools out after the workshop, all you need to do is go, if you work in a SOC, try some of the URLs that maybe come into your SOC with the passive analysis stuff, or just go to VirusTotal and find a couple samples that look bad and try the steps. So even though we're not making a fake, we're not building fake reputation for our fake exploit kit, because that burns a lot of cycles in SOCs. We don't want people to think that there's a real, like a new exploit kit that we've created, because it just wastes everybody's time. That's why we haven't done it. But if you guys want to try these steps, the passive analysis steps, with something real, just go to VirusTotal, pick a URL, and try it out and see if it works, okay?
And always make sure on VirusTotal you use the search, because if you put it in the first one, it'll actually upload it. You don't want to do that. So initial interaction. This is a really important phase when we kick it off, because what we want to do is we want to grab an entire copy of whatever is on the other end. So at this point, we don't know, is it a binary? Is it a bunch of JavaScript? Like, we have no idea. But what we want to do is capture it all as our organization would see it. So we want to make sure we use a user agent that all our users use. So if it's Chrome, Internet Explorer, Firefox, what have you. If you have specific regions that you operate in, you see a lot of this with banking Trojans. It will only fire if you're in a certain geographic region. So you want to be conscious of this, because if it's not going to target or exploit something in your organization, you don't care, right? Triage is done. You've done passive analysis. It is bad. We don't use this browser, so we're good to go. So the first thing you'd want to go to, if you don't already have it, is there's a site called useragentstring.com. You can go here just with your regular work browser. It's going to show you your agent string. It also lists agent strings for all the browsers that you can imagine. So lots of information. So you want to make sure you use the one that your corporation uses. Sorry. And like everything, there's an online curl. There's actually more than one online curl, because this one doesn't work. You have to use another one, but it's in the workbook. So the purpose of this, again, is we want to get our user agent, we want to go to online curl, and we want to pass in the same agent. And what's going to happen is we're going to see the request response, and we're going to want to copy this response body out into TextPad or Notepad or something and save it. And then we always want to work on copies of this copy. So that way, if the malware is, say, tagged to only 1 or 2 interactions, which we do see a lot, if it's time scoped, so it's only going to be live for an hour or 2 hours, you've grabbed a copy, it's your master copy now, you can work locally, and you don't care about it anymore. Like, we do not care about the URL. So now we can start doing some active things. So there's a site called URL Query, and what it does is it will pass the URL and any responses through a number of different IDSs. So again, like our passive analysis, we see that it's tripping a bunch of sweet orange signatures. It will also show you any weird JavaScript imports that are going on and give you a really good overview. So now that we've captured a copy locally, we have the payload from the initial interaction. We can start doing whatever we want to it. In this case, if it was time boxed to 1 or 2 times, we have ours locally, so we can start using these other online websites. So time to do it live. So in the workbook, did everyone download the workbook that's sitting, I hope?
You guys need the workbook for this, because the slides don't cover the workshop.
So we're going to put the bit.ly link back up, and it has a number. It has 3 different URLs that you can use to hit the WebKit. And from there, what we want you to do is set your user agent and grab a copy of what's returned back.
So that bit.ly link that says workshop, click me. Once you open that up, there's going to be a Google Doc. And in the Google Doc, there'll be 3 URLs that you guys can choose from that actually host the exploit kit. So in the workbook, you'll see all we want you guys to do is open up online curl or hurl it, H-U-R, well, it's in the workbook. Open it up, browse to one of those links in the Google Doc, and download the body of it, copy the body of it into a notepad, and you're done. What we're going to do, it's normally we're going to try to walk around and see where you guys are at. This is starting off super easy. I know probably a lot of you are like, this is bullshit, this is so easy. But it gets really hard really fast if you don't follow along. So each one of the next steps builds on this step. And if you miss this step, you won't be able to do the next one. So it's really important that after we're all finished, we're going to do a walk around. If anybody didn't get it, what we'll do is we'll just come by and make sure that you get a copy of it. Okay?
Yeah, you could just do it. Yes.
You're on the laser.
We both decided not to bring laptops to try and travel light.
Yeah.
And it was a terrible, terrible decision.
I almost did it. Can you show it once, please?
What's this?
Well, we don't see from.
Yeah, I know. I'm trying to help you.
Maybe you read it aloud. So 1WB8 FF.
Okay, yeah, so I can't make this bigger because I have an iPad and I don't know how to use an iPad. So I'm going to read out, this is so embarrassing. I'm going to read out the bit.ly link, but I'm going to read it once, only once. Okay, so everybody get ready to type really fast. Yes, that's good. Yeah, you got it. Okay, 1 W B 8 F L B. Bingo. No, they're not. 1 capital W, capital B, 8 lowercase f, lowercase l, capital B. Are you guys? Yeah. So I'm not sure if you guys have the same jokes as we have. I've never been to Russia before. I don't know. But in Canada, we call this a clown show. So when your presenter's screwing up, it's called a clown show. So this is the clown show, guys.
Oh, we have 6 minutes. This one's pretty fast. Is everyone getting it? Now that you have the URL?
Yeah. So I should also mention in the workbook, when you guys have downloaded it, it follows along with the slides. So you'll need to scroll down until you get to the first workshop slide. Like if you guys just open it up, if you haven't noticed, it's a big PDF, and we have slide and then notes, slide and then notes. You'll just have to scroll down to find the first workshop slide, and that's where the instructions are. Again, normally this is printed out. We do apologize.
Save the trees.
It was just impossible. We tried to get it printed and it was not. Language barrier was too much, and the time difference. It's crazy.
Yeah, and you have a copy of the in the Google Doc? Yeah. So have you been able to download the copy? Yes. So you need to go through, you need to download a copy of the
Does it work? Good?
Yeah, so this is right, but then you need to download the source code.
Sorry, so the link for the actual stuff to download right now is inside that Google Doc documentation, right?
Yeah.
First or anything.
The first link to the PDF is the workbook, and then there's 3 links to the exploit kit. You can use any one.
So it's page 40 on the workshop, right? Page 40.
Yeah, it's page 40 in the workbook, if you haven't seen it. I also see some people aren't setting their user agent strings. If I was an evil hacker, I would block you. If you are bored, there is a backend that is quite hackable and hilarious if a bunch of you hack it and can start doing stuff to each other.
You can actually copy it. Maybe it's me.
Excuse me.
No, they're the same. Yeah. Yeah, just one time and copy the body response and see it. You guys are good? Yeah. You guys hear back? Is it working? I guess so. So we did make it that you guys haven't tried it. Yeah, you have to insert it out. So I'll give you a hint. It doesn't have to be an actual user agent. Just
Excuse me, guys.
Yeah, we didn't keep it, we have another idea for one with more binary stuff, but triage, we kind of need to keep it so it's complicated, but a lot of them are not.
I'm sweating. Sweating so much.
So it looks like most people got it.
Should we proceed ourselves or wait for your?
No, we're gonna go now.
We're gonna start.
Okay, guys, we do have to proceed. What we're going to do is, if anybody didn't get it during the next workshop, we'll come by and we'll give you a link that gets you what you need to do to complete the workshop. For those of you who did it, you should be looking at in a notepad. You should be looking at some HTML code that looks kind of like this. This is just an example. There's a bunch more code, but make sure that you have this sitting there in your notepad. And for all the workshops going forward, for all the next sections, make sure you make a copy of this and you work off the copy, because you need to keep the original intact in case you make a mistake or something. So just make sure you have this in a notepad. If you have this, it means that you okay, it means that you've completed this successfully. Okay, so moving on to web component analysis. And I will mention, I noticed that as I was walking around, some of you got this like right away, and some people were struggling. It's really hard, like I'm sweating through my shirt here trying to get around to all you guys. It's really hard for me to reach, especially the guys in the corner. So maybe if you notice your neighbor's having some trouble, or if you're having trouble and your neighbor has this, maybe just try to help each other, because it's very hard for me and Sean to reach everybody, okay? So moving on to web component analysis, this is where we actually get into doing some work. So now that we have a copy of the HTML and JavaScript, we want to take a look at it and see what it's doing. So with most modern exploit kits, you can't just go in there and take a look at it, because it's going to be obfuscated. It'll be encrypted or obfuscated, and depending on what exploit kit you're dealing with, it may be very advanced or very simple. What we're teaching here, this component, the web component analysis steps that we teach you, are going to work no matter how difficult, no matter how obfuscated the exploit kit is. These steps will always work. All that's going to need to happen, if it's very advanced, is you'll just have to repeat the process multiple times. So you'll do 1 pass, 2 pass, 3 pass. Today we're only doing 1 pass because we don't have a lot of time. We want to make it simple. But in the real world, nothing will be as easy as what we show you today, but you can use the same steps. So basically, when we get into this, the deobfuscation process is really just understanding what's written in the code. So you need to be able to read some JavaScript and some HTML. You don't have to be great at it, but you do need to understand the basics. One tool that really helps doing this is JS Beautify. So JS Beautify, you can put in, it basically all it does is it adds new lines and white space to JavaScript and HTML. So if you look at a modern exploit kit, it's just going to look like a wall of text. You're not going to have any line breaks or anything like that. It's going to look crazy. But if you put into JS Beautify, press go, it's going to add all the nice white space and new lines and everything, and it's going to make it look semi-readable. It's not going to make it great, but it's going to make it semi-readable. This is the first step. You want to get it into a format where you guys can actually read what's going on. Right? So JS Beautify is perfect for that, and we're going to see as we go through this, you guys are going to keep going back to JS Beautify to make each step to make it clearer and easier for you guys to read. So WebOet is dead. Anybody who used WebOet, it's dead now. We really don't teach automated JavaScript tools that automate JavaScript analysis. We don't think they're very useful. If it did work for you guys, then maybe you're magical, because it's never worked for us, and now it's dead. The process that we're teaching is manual. There are ways to automate this, but we're not going to go into it today. So everything we do today for web component analysis is going to be manual. It's going to be you guys actually reading the JavaScript and figuring out what it does. There are 2 ways to deobfuscate JavaScript, the safe way and the not safe way. The safe way is to take out all references to the DOM. So you copy out your JavaScript into a notepad. You find all references to the DOM and you change those into variables, assignments to variables. And then you run the JavaScript in a JavaScript runtime environment that's not browser-based. So there's tons of these online. They're just JavaScript engines that don't have the DOM component. The reason why you do this is because it's very safe. If there's any exploits or if there's any callouts or anything like that, they're not going to work because there's no DOM. There's no concept of a DOM in the JavaScript engine. We've given an example of the Chapman one. This is an academic JavaScript engine. We like it because even though it looks terrible, they have really good error handling. So they'll tell you if you've made mistakes. They have very comprehensive error handling. But it is kind of a mess to actually look at the view of the JavaScript. But the thing is, if you're going to be doing this for real, the safe way is too time consuming. It just doesn't work. So for us, like Sean and I on the job, we do this the dangerous way, the quick and dirty way, and it's what we're going to teach you guys today. We just show you the safe method in case, in case you have problems or you're really not confident in doing it the quick and dirty way. You can do it the slow way, but we don't recommend it. We do recommend doing the quick and dirty way. The quick and dirty way is just using it, running it in your browser with a debugger, right? I mean, you just do it live. So the safe way to do this is you go through and read the code that you've kind of slightly deobfuscated using JS Beautify, so you can now actually kind of read it. And you look for all instances of JavaScript execution. We call these dangerous JavaScript calls. So these could be like a document.write or an eval. These are very common ways to execute JavaScript. There's a few other ones, but the list is exhaustive. It's not impossible to find all these things. You find them all. You replace them with an assignment to a variable. So if you had like string eval of a string, instead of eval, just replace it with assignment to a variable. We call this defanging. It's a term probably used widely in this industry. We call it defanging JavaScript. So basically, all you want to do is just assign it to variables. You call it defang1, defang2, whatever you want. You also want to put a breakpoint below that variable because you want the program to stop execution so that you can take a look at what was going to be evaluated. This is basically your one-step process in a this is the first step in a two-step process to deobfuscating JavaScript. So remember, just find all of the dangerous calls, so evals or document.writes, replace whatever was going to be evaluated, whatever was passed to that function, with an assignment to a variable, and add a debugger breakpoint above it. We have an example in the workbook about how to actually do this, so you don't have to worry too much about how it's done in the slides right here. I will also mention that we are big fans of Google Chrome, so we recommend that you use Google Chrome here because it's easy for us to troubleshoot. It's also easy for us to troubleshoot IE, so if something is going wrong, it's easy for me and Sean to go in and say, okay, you're doing this. If you guys have to use Firefox, if there's like some diehard Firefox users, go for it, but you might be kind of on your own because Firebug works a bit different and it's harder for us to troubleshoot. So we do recommend using Google Chrome or IE. If there's anybody in here who hasn't used the debugger in the browser before, it's very much like a debugger that you would use with a binary. So basically it has breakpoints, step-by-step execution, all the same stuff, only it's debugging JavaScript. So in order to open it, again, we have specific instructions for Chrome in your workbook, but basically there's just a drop-down for developer tools. You open it up and you get this view that's on the slide here. One important note is that in the slide here, we have on the right-hand side, my right-hand side, your right-hand side, I think, we have a panel that shows you all of the assignments to variables. So if you're looking so if you've stopped at a breakpoint and you want to see what was assigned to that variable, you can scroll through that panel. The only problem, and we're going to go through this again in the workshop, but the only problem with this is that all of the variables in the DOM are listed there. So there's a quicker way to actually look at, I am really sweating. There's a quicker way to look at the variable, and that's just to hover your mouse pointer over top of it, and it'll show you whatever the contents are in the variable. It's just a quick trick. It's in the workbook as well, but I wanted to mention it. So in our sample example here, you may not be able to see it on the slide, but you can definitely see it in the workbook. You can see that our variable here has some JavaScript in it that's being executed, or that would have been executed if we let it run. So that's on the red there, you can see there's a bit of, there's some HTML code and some JavaScript. If we pull that out and copy it again back into JS Beautify to take a look at it, we can now see what was obfuscated. We can see that there's some tricky stuff here. So it looks like they're writing some more JavaScript to the DOM. Again, you guys might not be able to see it in the slide, but you can definitely see it in the workbook. They're writing 3 different things. They're writing 2 Java objects and 1 Flash object. And this is what we're usually looking for. So if you guys are doing exploit kit triage and you're doing deobfuscation of JavaScript, you're going to generally be looking for either a Flash instantiation or a Java instantiation, maybe like an RTF document opening or something like that. But generally today, even though Java's kind of dead now too, today it's mostly Flash stuff that you're looking for. And these are going to be where your exploits are located. So you see a bunch of obfuscated JavaScript, you deobfuscate it enough to see what's actually going on, and you'll usually see it running a Flash, instantiating Flash or instantiating Java, or maybe again, we won't go into too much detail, but maybe again, there's some other stuff that you might see. So for the purpose of this, for this workshop, we're only going to focus on Java because it's very easy for people who haven't done any development before. It's very easy to understand the code. I understand that Java is not as common today as an exploit vector, just because a lot of companies don't run it anymore. But for you guys, just for the ease of the workshop, the process we show you is the same, but with Flash, it's a little bit more difficult. And if you have an IE browser exploit with shellcode, it's much more difficult. So we don't want to show you guys that today. That's much more in depth. We're just going to show you Java. It's a little bit easier to understand. It's easy to decompile. So in this case, in our sample, we have a Java applet that's being instantiated. We can now see the parameters that are being passed to it. this is a side note, but if anybody's not familiar with base64 encoding, I'm just going to quickly outline what it is today. So it's a way to encode binary as a string. So the way that you notice base64 encoding is you'll see that there'll be 2 equal signs on the end of it, or 1 equal sign. This is the padding in the encoding. Base64 encoded strings don't always have this padding, but if you see that padding, you know that it's definitely base64. So it's just a pro tip, if you guys are going through deobfuscating stuff and you see some strings that have equal signs on the end, it's always worthwhile just to throw them into a base64 decoder just to see if they show anything interesting. So it's just a side note here. There's a tool, base64 decode, it's online. I just thought I'd show you guys that. There's a bunch of other tools that go along with this one that are other encoding tools that are in your workbook if you guys want to try it out on the side. You probably won't need it for the workshop today, but I do want to show you that because it is one of those tips where you can really quickly, if you see some strings, you deobfuscate them, and then right there is the exploit that you're looking for. So again, like I was saying for the workshop, we're going to go around. If there's anybody who hasn't used the Chrome debugger before, we'll go and help you guys first. So maybe even just raise your hand. If you're completely lost, you don't know what's going on, we'll come to you first. And again, if anybody here is like a wizard, you do a lot of like analysis yourselves for your job or whatever, maybe try to help your neighbor because it is very difficult for us to get in to help people, especially along the wall there. So just the 2 tips that you'll want to use if you haven't used the Chrome debugger before, to actually open the debugger. It's the top right-hand like options button. It looks like a bunch of lines in Chrome. You click on that, then more tools, and then developer tools. One tip is if you don't have developer tools open, if you don't have the debugger open, and you use the debugger breakpoint in your JavaScript that you're trying to deobfuscate, it's just going to hop right past it won't stop on the breakpoint. It'll just run right past it. So it's important that before you run the JavaScript that you've put the breakpoints in, that you open up developer tools. Otherwise, it's not going to work, and the exploit's just going to run. So it probably won't own your computer, but just be careful of that. Also, as I was saying before, we've just given you a quick demonstration of how to look at the variable with the mouse hover. So again, when you have the debugger tools open in the right-hand panel, there is going to be a list of all the variables, and you can see all the values that have been assigned to them. But if you can't find the variable that you're looking for there, you can always just hover your mouse pointer over top of the variable for a minute. Be patient, give it a minute, and it'll pop up with the contents. So here we can see we're hovering over one of the variables. We can see that there's an alert being passed to it. So we're going to do it live. For this one, it's really important that you guys have the workbook open because it explains the steps in a lot more detail than the slide that I'm going to show you guys. So, and it has the tips so you can actually read them. So go forth and we will walk around. I think you get 20 minutes for this. Yeah, you do. You get a bit of time. So again, if anybody is really lost at this point, raise your hand and we'll come to you guys first, okay?
Oh, the debugger, yeah, I guess I could.
So in the workbook, it's page 58, okay? 58. Also, I don't see any hands for help. So is there anybody, I just want to make sure, is there anybody who didn't get the first section who doesn't have the HTML code? Okay, there's one person, okay.
Oh, yep. We use PDF. Like, you need a PDF with those. Yep, yep, we can send that. Is it 2 or 1 o'clock? 1 o'clock, right? Yeah, yeah. Do we have to finish a bit early? There's someone right after us, I think, right? Yeah, I saw that. Yeah. Okay, cool. Thanks. Working? So, if you look right here, see how it's doing the valve? So, you put a breakpoint right there. And you can add a breakpoint. See, I like the 30 dollars. So then, so by defanging, what we'd say we're going to do is remove the valve, and we'd say defang was because what's happening is it's running through the it's setting, you can see here, it's setting up, and then it's actually, so now if you refresh the page, now highlight that there. It's checking if the reference is PHDays.use and yeah, boy, do is copy
Yeah, there's other functions, but not for the workshop. The workshop is just yeah, and you want to add a break. Okay, so what you do is for your
or maybe just, I can't do everything. Oh yeah, sure. Oh, so because what it's doing is can you add breakpoints?
There you go, breakpoint. Okay, so take a look at what's
oh yeah, that's yeah, so that's essentially what you get in the other one, but what's happening is yeah, probably doesn't get
and
it's for
look at what's happening.
so you're seeing the image the issue or the danger with some of the automated tools that I see is now we're out there so there'll be things that will trip is that wrong?
This is okay, but if you set a break,
So I think it's
you can see that this was
does it go to the
you can still see it, but you want to look at the source code. Because yeah, this has to be beyond here. So if you add a break.
yeah, that's bad. So what I would do is I would take that out. And then type the whole thing, yeah, and then type debugger.
Yeah, that's right. And then so you want to
Try to
this is the last one.
So in iSQL, is there a way that you can look at there's another way.
But this looks interesting, right? Yes. So when you try to download a copy of that, just save a copy to your yeah.
Is that the case? Oh yeah, there's no
Oh
So now you highlight. So what happened is it ran through this deobfuscation function and then it wrote it down, but it would have passed the deobfuscated question. Right? So that's why if you find all like vowels and replace them with a variable or just delete them and then put them in others, you can see what it is. They're all Well, so there actually is one. So if you scroll over there, you can see that so it's glass. It's over here. Oh, here it comes from. Sources. Now refresh it. So then, so what you normally do is say, you retrieve that. So that's why it's usually safe if you never do it on your actual virtual machine, the fastest way to just look at the where's all the allies, replace them. Yeah, you can. So that's one of the benefits of the reason we didn't tell people to use this is because you were being malicious. It's really easy to protect applying your upgrade. Copy that. So you guys all good? Yeah. So the reason why it's not set up yet is because it hasn't been so yeah, that's exactly how you do it. No, because you commented there. So it's just it's decoding our particular so it ran through
Oh, Mozilla, yeah.
No może pytać, to ci интересно, бинарные тоже не очень. Ну, можно гулять, можно на самом деле здесь потусить. Взять, чувак просто. Мы там пройдем. Ну, я бы сейчас тут потусил. Сейчас будет неинтересно, потому, в принципе, просто в этой крови не могу сейчас.
Okay, so just for everybody, I think most people have this, but we're just going to give you an example of what it would look like for anyone who's still trying to catch up. So you should have seen this. You'll see that this is the variable that you've assigned, that you've defanged the eval to. And if you set a breakpoint and you stop on it, you can see this was the code that was actually going to be executed by the eval. And you'll see there's something kind of clever here. I just want to explain, because I did have a few questions about this. You'll notice that we actually check for a refer to be the PHD site. The reason why we did this is because this is live malware on the internet, like anyone can browse to it. So we wanted to set a refer that nobody would ever have. Like there's no way to have this refer unless you manually set it. So this is our safeguard so that nobody gets mistakenly exploited by this. So that's why it's set up like that. We always put in like the conference name just because it's kind of cute, but we could put whatever we want in there. It was just so that nobody else would be exploited by accident if they stumbled across this. In the first line there, you can see that if you did match the refer, you got the mayor or the police officer saying nothing to see here, the image, and you also saw I'm not sure, There we go. So you also saw that on that line, there's a class file. And for those of you who aren't familiar with Java in the browser, this is actually instantiating an applet. So this is, again, Java is not so common nowadays, but this is what you would see a lot in older exploit kits. So you'd see basically some JavaScript that's then loading an applet. And you'll notice the applet size is 1 by 1, so nobody can see it. It's obviously, this is very suspicious. So what we wanted you guys to do, the final step in the workshop, was to download a copy and save a copy of that class file, because you'll need it for the next part. So, right, so yeah, so I'll explain. So you'll notice that there's no reference on the class file. So this is because it's a relative path. So the path to get this class file is the lasercats.tk/images/pew/pew.class. So if you looked at those original links in the Google Doc, it's lasercats/images and then a big long URL or a big long string. Just get rid of the string and replace it with pew/pew.class, and you'll download the file. You just do that right in your browser. Your browser will automatically just download the file. I did notice one of you guys had like AV turned on, and it did kind of flag. So if you do have AV turned on, it's going to flag. And I think most people have completed this. Again, we'll do the same thing we did for this workshop. If you haven't got this file downloaded for the next workshop, we'll just have you raise your hand, and we'll go around and make sure you have a copy of it. Okay. Okay, so now that we've downloaded our exploit, we're going to have to take a look at it. Now, this is where, up until today, or up until this point, the process that we've been following is pretty much the same process you would be using if you were actually analyzing malware for real. So you're not using triage. This is the part in the triage process that becomes triage. So you wouldn't actually be doing this if you're doing full analysis. This is only for triage. And what we're actually doing with exploit analysis is we're not going to be using a debugger to try and figure out what the actual flaws are. All we're doing when we do triage of exploit analysis is we're just trying to match the exploit code with publicly available exploit code. So we say, like, it's maybe this CVE number, we get a copy of that CVE code, so, a public copy of it, and we match it up and say, yes, it is this code. Now, you might be saying, well, that's not going to work. It actually works surprisingly a lot. So most of the exploit kits that we see out there are using public ODays. They're not ODays, they're like, a year old. And the source code is publicly available on Metasploit or on exploit days or whatever. Like it's everywhere. So it's actually quite easy to do this. And the trick here is that if you're unable to match the code, this should only take a few minutes. So that's why we say triage. It's very quick. So I know today it's taking a bit longer, but once you start doing this a lot, it'll only take a few minutes. And to do this, if you don't match any code, if you don't match a publicly available exploit, this is actually a good stage where triage becomes analysis. So if you can't match that exploit code, if it's not publicly available somewhere, this is when you stop your triage. And today you're going to be able to match it because we want to go through the whole process. But in the real world, if you were unable to match it, you would stop triage and you would pass this on to your incident handlers because it's already kind of raised up in treble. You know that this is a bit more serious. So that's basically what we're going to be doing today. It's just basically pattern matching for exploit analysis, but we'll show you some quick tricks to do so that you guys can do this fairly quickly. So the first trick, it's not really a trick, is to upload it to VirusTotal. So like I said before, OPSEC warnings, right? So if you think that this might be an ODay, maybe you don't want to upload it to VirusTotal. But if this is like a generic phishing email that says like "Dear Sir or Madam" with like some spelling mistakes or whatever, it's probably safe to upload it to VirusTotal. So what you can do is upload that class file to VirusTotal, and you'll probably get a couple hits. If you don't get any hits, maybe this is a good time to kick off some actual incident response, because maybe there is something tricky going on. But usually you'll get a couple hits. There'll be an AV signature for it, which will give you a CVE number. You can't trust that CVE number. All it is it's just a base to start looking. So it's just a good reference to start looking. If you don't get any CVE numbers, then again, maybe something weird is going on. But I would say, like, I think Sean and I mean, we do this every day. So I would say like 99% of the time you get a CVE number because it's an exploit that's been out for months and months and it's publicly available. So in this case, we get an older CVE number because it's Java, so it's like 2013. And what this does is this says, go out and find, this is what it's telling us, is this could be the CVE number. So go out and find a proof of concept for this CVE, find the source code for it, and compare it to our source code and see if it matches up. So a quick tip, we just threw this in here because a lot of people maybe don't work with Java every day. So we've actually given you guys a class file. Normally, when you have an applet, you'll have a jar. A jar is just a zipped bunch of class files. So if you guys aren't familiar with this, if you come across this, in the real world, it probably won't be a class file. It'll probably be a jar file. All you want to do is just change the jar extension to zip, and you can unzip it, and it'll be a bunch of class files. So I just want to throw that in there in case you come across this in the real world. So, excuse me. So how do we actually compare the code, right? So with Flash and Java, they're written in such a way that you can actually decompile them back to source code. So you don't need to disassemble them. So it makes it a lot easier to actually match the code. And better than that, you can actually decompile them online. I think somebody already found this site. But basically, we like to use Show My Code, which is an online site. You upload the class file, and it'll decompile it back to Java. And then you can just read the Java code, right? I mean, you don't even have to understand Java. You just have to look at the strings in it to see what's going on. Java is very straightforward. So if you've done any programming at all, Java is like the easiest to understand what's going on. And this works the same for Flash with ActionScript. The reason why we haven't chosen Flash is because it's less easy to understand the code, but it'll work the same way. So if you guys have an SWF you want to see, upload it to Show My Code, and it'll decompile it right back to source code. So now that we have the source code, we have a CVE number, we might want to try and match them up. But the people who are writing this malware, the people who are writing exploits, know that it's very easy to decompile jar files. It's very easy to decompile SWF files. So what they do is they actually add extra obfuscation to that code even after it's decompiled. So when you decompile it, you're not going to see nice Java code. You're going to see kind of what we saw with JavaScript. You're going to see big, long character arrays of crap that you don't understand. Our job is to try and deobfuscate that to the point where we understand what the code is doing so we can compare it with the CVE proof of concept that we found on the internet. So that's all we're doing. This whole step is just trying to deobfuscate enough that we can match it. We can match it maybe with a Google search for some strings, or we'll show you another tip where you can actually go and compare in GitHub and see if the code matches. So in order to do this, the first step is to decompile it. So you'll upload your class file to Show My Code, decompile it so you can see the Java source code, and save that Java source code to a notepad. Then what you need to do is you need to actually execute the Java code in order to do some deobfuscation. So you could manually do this offline, so you could go through and read all the code and try and figure out what it's doing, but who has time for that, right? Ain't nobody got time for that. So what you want to do is you want to find an environment where you can execute the Java safely. And what we've provided to you, this is awesome tools that are, well, we haven't provided them, we found them, but they're online tools that will allow you to compile and run JavaScript or Java, Flash, all kinds of different languages, Ruby, whatever you want, Python. There are these online environments where it's run completely on the server. It's not run locally, so you have zero exposure. There's no problem. If things get away from you, it's not your house that's burning down. So we use IDE 1. There's also another one that's in your workbook that's maybe a little bit better. It has more environments, but IDE 1 has Java, and it works just fine. So what you'll want to do is you'll want to copy the saved Java code up to IDE 1. And then here's the thinking part. This is the only tricky part in the whole process. And that is that you're going to have to do a bit of guesswork. So you're going to have to find things that look like they're obfuscated. So generally what this looks like is either arrays or strings that don't make any sense. So like a string that's a whole bunch of gobbledygook, or an array that's just a giant array, it's maybe 100 characters long or something. You're not really sure what it is. If you see a bunch of those defined, look through the code and see where they're used. And usually what you'll see is they're passed to the same function again and again before they're used. So let's say you have 5 long strings that are garbage, you don't really understand what they are. Locate where those strings are used in the code and see if they're passed to a function. The function is not going to be called decrypt me, but it's going to be called something, and see if it's the same function every time. If it's the same function every time, it's probably going to be a deobfuscation function or a decryption function. This is when you can start to actually do your work. So once you've located functions that look like, there might be more than one, you don't care, right? You just, as many ones as they look suspicious, they look like they're actually deobfuscating the code, find them, copy them out into your Java runtime environment, pass the strings in as a function, and put a print statement on the return. So you don't even have to return, just print out the return value. And what that'll do is it'll tell you really quickly, did that deobfuscate the string, or is it more garbage, right? Did it print out garbage, or did it print out something that's interesting? And this is like, this sounds like kind of crazy. You're like, well, I'll never find it. But you will, because there's only so many ways that you can like obfuscate strings, right? They have to be used at some point. So as long as you follow that same process, so you find things that look like they're obfuscated, so either arrays or long gobbledygook strings, find out where they're used in the code, and see if they're passed to the same function repeatedly. And if they are, copy that function out, pass one of the strings in just as a sample to see if it works. And if it deobfuscates it, then you've located your obfuscated strings and your function. And all you do then is you just go through and deobfuscate each string, and wherever it's used in the code, you just copy it back into the code. So what will happen is you deobfuscate 1, and you copy it back in, 2, 3, 4. By the time you've done like 4 or 5 or 6, your code is starting to look like normal code. You'll start to be able to read it. And you'll see today, the process is very easy to follow. In the real world, you're probably gonna have to do this like, maybe 5 or 6 times. Here, it's quite easy. We've made it very easy for you. But that same process will apply no matter, there's only so many ways you can obfuscate stuff. The same process works every time. So in our example here, I'll just pop back for a second. In our example here, we have more details on how to use the integrated development environment, and we have sample code in the workbook. So you guys don't have to pay too close attention to this, but we are just showing you that we've taken this kind of gobbledygook source code, and at the bottom you can see, maybe you can't see on the slide, but at the bottom there, we've printed out a deobfuscated string, and all we're doing now is we're subbing them back into the code. And when we sub enough of them back in, you might not be able to see that there, but you should be able to see it in the workbook. When you sub them back in, all of a sudden this garbage code starts to look like something you can understand. And if you look closely here, maybe you can't look close enough, but in this case, they're actually loading a file, a random file with git resource, and then they're doing some work on that file. So by reading this code already, we can see that there's another file that we want to look at. And I won't go through it because it's too small for you guys to read, and it's not really applicable for the workshop. But in this stage, there was 2 stages of obfuscation. So the first one was to deobfuscate those strings, sub them back into the code so we could read it. The second stage is we notice that it's loading a file, and it looks like it's removing some strings from that file. So what we do is we load that file in a text editor. It looks like crap. We don't really know what's going on. But we do a find replace, remove that string, and all of a sudden, voila, we have a Java class file. So for those of you who are familiar with Java, you can see the first few bytes there, Cafe Babe, are the magic number for a Java file. So what we've done is we've gone from a fully obfuscated set of Java to deobfuscate and see that they're loading a file and they're removing some strings from it. We did the same thing. Now we have another class file, so we can upload it to show my code. There we go. Now we have some deobfuscated code. And the trick here, and this is the trick to matching your code with a publicly available exploit, is the more difficult it was to deobfuscate something, the more probability that that's the thing you want to Google. Because that's the thing that the virus developer has gone extra effort to try and protect. So this is usually what you want to look for. So in our case, this is the code that we'd want to try to match, because it's the stuff that they did the extra steps to try and obfuscate. It's just a trick when you're going through. You probably won't need it for the workshop today, but it's just a handy trick. The more effort they put into it, the more likely that that's the jackpot. That's what you want to look at. So like I said before, there's really 2 ways to match it up. So if you didn't get any hits in VirusTotal, but you've deobfuscated the code and you've noticed they've taken extra effort to obfuscate some strings or some source code, you could just put that into Google and see if anything pops up. Put in some of the strings and Google and see if anything pops up. But if you did get a CVE number, the Metasploit GitHub is pretty much like our go-to. They have almost every exploit that I've ever seen in an exploit kit. Not targeted attacks, because sometimes they use more advanced stuff. But in exploit kits, like publicly available crimeware stuff, it's almost always been in Metasploit. So what you do there is just plug in the CVE number into the Metasploit Git. You find their source code. It's very nicely commented and everything. That's why we use Metasploit, because they really explain how the exploit works. And then you just compare that code to the code that you've deobfuscated. It doesn't have to match exactly, but if it matches, mostly, you've probably identified the exploit. It's probably the right one. And that's really all there is to exploit triage. Again, it's triage, it's not analysis. We're not saying 100% it's this. We're just saying it probably matches. It looks like it's the same thing. This is the process that we're going to use. So in our case, we were able to match the CV number, and we move on to payload extraction. Now, payload extraction is actually the same exact process, but it's with a different goal in mind. So like I said when we first started talking here, when you have an exploit, the goal of that is to get some code execution, right? That's why you're doing it. But you're not getting code execution for any old reason. You're doing it for a purpose, and that's the payload. So what you want to do here is you want to figure out, after the exploit is run, what does it do? Does it download something and run it? Does it extract something and run it? Does it just make one ping request? What's going on? And again, the process that you use to deobfuscate the exploit is exactly the same process that you use for payload extraction. You might actually even find, as you're deobfuscating the code, so as you're finding those Java strings, you're copying them into the function that looks like it's deobfuscating it. You're getting out the deobfuscated code. You're putting it back. You're subbing it back into your original template. You might actually find that some of those strings are the payload, right? You might find, oh, look, here's a URL. That's interesting. What's going on there? So it's the same process. It's just a different goal. So this is very short. And in the workshop, you're going to do both these together because, again, it's the same process. And we're just showing you here very quickly. We're using IDE 1 again. This is the online JavaScript or Java runtime environment. And you can see here that one of the strings that we deobfuscated at the bottom actually turned out to be a URL. So this, for us, if you see a URL, it's important to note it down, make note of it, because it might actually be where the payload is stored. And just a note on that, for anybody who's not familiar with the way that exploit kits work, usually the way they work is they either download something after the exploit is run, so they'll download something and run it, or they'll copy an obfuscated binary out of the exploit itself. So there'd be like a long string or something that's shellcode, and they'll run that. So there's really only two things you're looking for. You're either looking for a download and run or an extract and run. And in both cases, it's going to be pretty obvious once you deobfuscate it. If it's a URL, it's going to be a download, or if it's a big binary, it's going to be some shellcode that's run. This is basically the two ways that you can do something after you gain code execution. So we just put the slide up here because it's good for the workshop because it'll get you started on the next stage. But if you get some URLs in there that download binaries, always a good idea to upload to VirusTotal just to see if it is malware, if it's known malware. Just a simple trick. We'll cover this more in detail in payload analysis. That's the next stage. But just something to do to make sure that you have the right thing. So we are going to go through the workshop now. I'm not going to leave this slide up here because it's in the workbook. But for those of you who are not familiar with Java, this is all you need. This is the template that you need to follow in order to get your Java to execute. All you need to do is sub in the portions that you find in the exploit, sub them into this template, and run this template. It's we leave it in there because there's a lot of people who maybe haven't programmed in Java before. Even though it's easy to understand the language, some of the syntax issues like the class file name and stuff like that might be a little bit different. So if you guys are stuck, make sure you check this template in the workbook. Make sure that your code is following the same template, and it should be okay to proceed. For this one, this is usually the one that most people have trouble with, so we'll be walking around. Again, if anybody didn't get the class file downloaded, you need that for this section. So please raise your hand and we'll go to you first. Okay?
What section next? So we should don't call this show my code. Oh, 86. Yeah, so I'm just going to make an announcement.
So guys, it's page 86 in the workbook, okay? 86.
Yeah. So select your workbook and there's a template in there. Because you only want to copy the stuff that's interesting. So only the function that does the description and the strings. If you try to do this with the code, it's not going to run because it's an applet.
So just a quick note, guys, guys and girls. So when you guys have decompiled your code, so you've uploaded the class file to show my code, and you've copied that code out into a notepad, you can't just upload that to IDE1 and run it. It's not going to work, okay? What you have to do is you have to find the strings that look like they're encoded and the functions that they're passed to, and you have to use the template in your workbook. If you just copy the code right over and run it, it's not going to run. You're going to get a million errors. The reason is that that's an applet, and you're trying to run it in a CLI environment, so it's just not going to work. The only thing that's going to work is if you follow that template that we have in the workbook, and you only copy the functions that are doing the decryption, the things that you think might be doing decryption, and the strings that you pass into them, okay?
So we're probably going to run out of time, and they're going to yell and scream at us, so we'll allow you guys to cheat a little bit. So what we mean by finding the functions that are interesting, if you look at the decoded Java file, you'll see it calls runtime.getRuntime.exec, so it's executing something, and then it's passing in a function. I've renamed that function to decode. You can see in the Java file, it's called something else, a bunch of characters. So we know that there's 3 specific variables or byte arrays that we want to deal with. And this is essentially what it should look like.
Yeah, usually we have more time than
Unfortunately, we're completely out of time. So I just want to go through this really quickly. If you do it, it should have grabbed a file called badbadboys.exe, which a bug on my part is causing a 404. So we are going to fix that so you can download the payload. What we do then is basically see what does the payload do, right? Is it a rat? Is it going to be something that's trying to mine Bitcoins? Is it doing ad fraud? Like, what is the risk to the organization? And then we'd want to build indicators to help identify this in the future. And then that really ends off the triage process.
Okay, guys. So before you leave, so I just want to say, like, we've totally blown our time budget. This took way too long. So there's like another 2 hours worth of coursework that we can do for you. So what I want to say is, if there's anybody here who wants to continue, who's interested in this, I know we didn't even get to complete this second stage. Our emails are in the workbook. Send us an email and say, I was in your course, I didn't get to finish it. And what we'll do is we'll do two things. First, we'll send you examples of us having worked through these steps so you can go home and you can replicate it yourself. So you can see, like, did I do it right? Because we haven't had time to answer all the questions today. The second thing we'll do is we will set up a second workshop online to help you guys do this. So because we didn't get through even like half the stuff that we want to get through today, there's a lot of stuff in the workbook. If you're interested in doing it, and if you're interested in doing the next two sections, send us an email. We'll set up a time next week where you guys can all dial in and we'll actually run this for you guys properly. We'll have the right amount of time to do it, okay? So I'm sorry that we didn't get through it. It's too much without the preparation, without the workbooks, and with so many people. We didn't expect so many people. So again, our apologies, but we will make it up to you. If you do want to send us an email, we promise you that we will schedule this online. And if you don't want to attend the online thing, we'll at the very least, we'll send you out examples of how to do each workshop, each stage, so you can compare with what you've done with the way that we expect it to be done, okay? So again, sorry, this is it. We're getting kicked out. We got to go. So that's it.
Thank you.
You want a shirt?
You get a shirt. And we're going to leave the website up for the rest of the day. So if you got to the payload, you can still download it, figure out what it does, all that sort of fun stuff.